These directions say find the distance between each pair of points. We originally had problems like this. When we originally had problems like this, we would graph the points and then use the Pythagorean theorem to help us find the distance between them. But since doing that, we learned how to use the distance formula, and we used the Pythagorean theorem to prove the distance formula. So let's be reminded of what the distance between 2 points are. So the distance is going to be the square root of, and then what we're going to do is we're going to subtract the two x values and square that, and then add the difference of the two y values squared. And the reason this distance formula works is because of the Pythagorean theorem. So what this means is the distance for any 2 points, you can do the one x value minus the other x value, then square it, then add the y value minus the other y value, and then square it. You do the squaring first, then you add, and then you take the square root. So let's go ahead and use this distance formula to find the distance between these points. So I'm just going to write d equals, and I'm going to use our distance formula. So we notice we want to take the x value, the first x value minus the second x value. So our first x value is -7, and we're going to subtract the second x value, which is 5, and then we square that. And we're going to add to that the first y value, which is -2, minus the second y value, which is 0, and we're going to square that. Now we have to do our order of operations here. So inside this square root, we have some things in parentheses. So -7 minus 5 is -12, which is squared, plus -2 minus 0 is -2, which is squared. We cannot cancel the square with the square root because there's a plus sign in here. If it was multiplication, it would be a different story, but it's not. It's a plus sign. So we have the square root of 144 plus 4. Because -12 squared is positive 144. -2 squared is positive 4. And so d equals the square root of 148. And now we want to simplify that because in the chapter that we learned to simplify radicals. So we're going to think through this and think, okay, I want to find perfect squares that go into 148. Well, I know 4 goes into that. So this is, we could rewrite as the square root of 4 times, and dividing 4 into 148. That's 3, which is 12, 28, 37. And so this is really equal to, well, the square root of 4 is just 2 times the square root of 37. That's a prime number. That can't be simplified anymore. So the distance is 2 root 37. If you wanted to, you could put that in your calculator and find an approximation. It's just a little bit over 12. All right, for this next one, we're going to do the same thing. We're going to use the distance formula. So d equals the square root of our first x value minus our second x value, and we want to square that. And then we're going to add our first y value minus our second y value, and square that. So that's going to be 7 minus 0, that's 7, so 7 squared. 3 minus 1 is 2, 2 squared. These were simple ones, but be careful when you have maybe 7 minus -5. When you're subtracting a negative, remember that's the same as adding, so beware of that in these problems. And then 7 squared is 49, 2 squared is 4. So d equals the square root of 53. And that's prime. You can't simplify that, so that's the answer to that one. That's the distance between the point 73 and 0, 1.